Lesson 2-1, Open Sentences and Solution Sets. So in this video, we're just going to be trying to determine what is an open and what is a closed number sentence, and then determine what the solution set would be for these open sentences. So let's first look at some vocabulary words. Algebraic equation is just an equation that contains numbers, operators, variables, and an equal sign. That's important because an expression does not have an equal sign. Open sentence is an equation that contains variables that represent an unknown quantity that are neither true nor false. So it's just a statement. So an example, 14 is equal to 1/2 times 7 times h. H is the unknown. We don't know what that would be, so we can't say this is true or false. Closed sentence is an equation that contains no variables and are either true or false. So if we take that same example, if we said 14 is equal to 1/2 times 4 times 7, 14 does equal 14, so we would say that statement is true. And then a solution set is just a set of numbers that are solutions to the equation. So if we look at the closed sentence where we said 4 was in place of h, we would say that 4 is part of the solution set for that equation. And the replacement set or the domain set is just a set of numbers that can be substituted for a variable in an equation, but it doesn't mean that it is an answer to it. You would have to plug those numbers in to determine which ones would be a solution. So let's take a look at an example. Here we want to determine whether the given value of the variable makes the open sentence true or false. So here we have 5 times m plus 7 equaling 5m plus 7 when m is equal to 3. So if we put 3 in for m, so I'm going to do that on both sides. So I'm going to have 5 times 3 plus 7 equals 5 times 3 plus 7. Now this side, the left side, I have 3 plus 7 is 10. 10 times 5 is 50. And this should equal 5 times 3 is 15. 15 plus 7 is 22. Well, 15 doesn't equal 22, so we would say this statement is false. And we can also say that 3 is not a solution to that equation. Next, 3k squared plus 18 equals 30 when k is -2. So let's test that out. So we have -2 squared is 4. 4 times 3 is 12. And if I add 18 to both sides, or to this side, 18 plus 12 is 30. 30 still does equal 30. So this statement is true. And we can say that -2 is a solution set to that equation. Next, we want to identify each as an open sentence, a true sentence, a false sentence, or an expression. So 2 to the 5th is the same as 5 squared. Well, 2 to the 5th is 32, and 5 squared is 25. So we would say this is a false statement. Next, -7x squared. Since there is no equal sign, we know this would be an expression. And it can't be an open sentence or a true sentence only because it's not an equation, and those sentences have to be an equation. Next one, 2x plus 5 equals 13. Since it has a variable, it's an equation. We don't know if it's true or false, so this would have to be an open sentence. Next one, 8 plus 2, 3 times 2 equals 14. Well, 3 times 2 is 6. 6 plus 8 is 14. So 14 does equal 14, so this would be a true sentence. So again, to determine if it's true or false, you have to have a number to put in for the variable. And then you determine if it makes it the statement true or false. Next one, 10 equals half times 8x. For that one, it is an open sentence. And it's an open sentence because it has a variable. It's an equation. We just don't know what the variable is, so we can't say if it's true or false. Next, these types of problems, we're going to replace this. We're going to use the replacement set, -2, 0, and 2, to find the solution set for the open sentence of 3c squared minus 1 equals 11. So I already put all those numbers in. We just have to determine if this is true or not. So -2 squared is 4. 4 times 3 is 12. 12 minus 1 is 11. The absolute value of 11 is 11. So yes, this works. Next, 0 squared is 0. 0 times 3 is 0. 0 minus 1 is -1. Absolute value of -1 is 1. 1 does not equal 11. So this is not a solution. And if I put 2 in there, 2 squared is 4. 4 times 3 is 12. 12 minus 1 is 11. Absolute value of 11 is 11. 11 does equal 11. So yes, this is a solution. So my solution set would be -2 and +2. Next, use the replacement sets, -2, -1, 1.2, 2, and 4 to find the solution set for the open sentences below. So we're going to plug those numbers in. So for D, we have -2 plus 5 equals 9. That is not correct because this would be 3 equaling 9, and 3 does not equal 9. What if we try -1 plus 5 equaling 9? That does not work because -1 plus 5 is 4. 4 does not equal 9. Next, if we put in 1.2 plus 5 equaling 9, that does not work because that's going to give us 6.2 does not equal 9. And if we try 2 plus 5 equaling 9, that does not work because 2 plus 5 is 7. 7 does not equal 9. And if I try 4 plus 5 equaling 9, this is true because 9 does equal 9. So for this one, the only set that would be true would be 4. Next one, we have 8 equaling 3g minus 4. So we're going to do the same thing. So we have 8 equaling 3 times -2 minus 4. 3 times -2 is -6. -6 minus 4 is -10. 8 does not equal -10. So this one does not work. 8 equaling 3 times -1 minus 4. This would be 8 equaling a -7. That does not work. And if I did 8 equaling 3 times 1.2 minus 4, 3 times 1.2 is 3.6. 3.6 minus 4 would be 2.6. So 8 does not equal 2.6. And then if we have 8 equaling 3 times 2 minus 4, 3 times 2 is 6. 6 minus 4 is 2. 8 does not equal 2, so that's not a solution. And 8 equaling 3 times 4, which is 12, minus 4, which is 8. 8 does equal 8, so yes, that is a solution. So the solution here would be 4. So 4 worked for both of our equations here. Moving on to our next problems. See, it says use the same replacement set to find if these are solutions. We'll do the same thing here. So we got 2k minus 3.6. Now, instead of the k, let me put down the number here. So we have 2 times negative 2 minus 3.6 equals 0.2 times a negative 2. So we have negative 4 minus 3.6, so that is a negative 7.6. Does that equal negative, so this would be a negative 0.4. That does not work, so no, that's not a solution. If we try negative 1 minus 3.6 equaling 0.2 times negative 1, negative 2 times negative 1 is negative 2, minus 3.6 would give us negative 5.6. And I know that 0.2 times negative 1 does not work. So let's do 2 times 1.2 minus 3.6. Let's see if 0.2 times 1.2 works. 2 times 1.2 is 2.4. So 3.6 minus 2.4 would be a negative 1.2. And this side would be 2. If I did 2 times 1.2, let's just do that quickly on our calculator. So 0.2 times 1.2 gives us 0.24. 0.24 does not equal the other side, which we said was a negative 1.2. So no, that doesn't work. And let's try 2. 2 times 2 is 4, minus 3.6 would give us 0.4, and 0.2 times 2 would give you 0.4. Yes, that works. And then if I did 2 times 4, which is 8, minus 3.6, so 8 minus 3.6 would be 5.6. And over on the other side, 0.2 times 4 would give us 0.8. No, that doesn't work. So the only solution here would be 2. And then the other side here, we have negative 2 squared plus 11 has to equal 1.5. Negative 2 squared is 4 times negative 1 is negative 4. That's 7. Plus 11 is 7. So 7 does not equal 1.5. Try negative 1 squared plus 11. Negative 1 squared is 1 times negative 1 is negative 1 plus 11 is 10. 10 does not equal 1.5. So try 1.2 squared plus 11 equaling 1.5. 1.2 squared, think of that as 12 squared. 12 squared is 1.4 or 144. But I would have 2 decimal places, so that would be 1.44 or negative 1.44 plus 11 is not going to equal 1.5, so I know that's not true. And if I did negative times 2 squared plus 11, 2 squared is 4 times negative 1 is negative 4 equals plus 11 is 7. 7 does not equal 1.5, so that's not a solution. Try a 4. 4 squared plus, or 4 squared is 16 times negative 1 is negative 16 plus 11 is negative 5. Negative 5 does not equal 1.5, so there is no solution. We would say this is an empty set. Moving on to next one, last one here, we have put negative 2 in for n. Negative 2 squared equals negative 2 squared. So this side is 4. This side would be 4. So yes, this works. If I did negative 1 squared equaling negative 1 squared. 1 does equal 1, so yes, that works. And if I put 1.2, 1.2 squared and negative 1.2 squared, that's going to give you 1.44 on both sides, so yes, that works. And if I did 2 squared is equal to negative 2 squared, that is also working because that's 4 equaling 4. And the last one, 4 squared equaling negative 4 squared. Yes, that also works. They're both equaling 16. Now, because of the negatives on the inside and we're squaring it, when you square a negative, it's always going to be positive. And since the numbers we were putting in were the same, they're all solutions. So the solution set would be negative 2, negative 1, 1.2, 2, and 4. And some word problems. Soup is on sale for 99 cents per can. The number of cans a customer can buy is limited to 5. Write an algebraic expression to model the cost of a number of cans of this soup. Tell what the variable represents and write a domain set for that variable. So this actually is where our equation is going to be. So we're going to have 0.99 times C for can. So that would be our expression. So now you're limited to 5. So that means our set would be, I can buy 0 cans, 1 can, 2 cans, 3 cans, 4 cans, or 5 cans. So that would be the domain set that we could use to find out what the cost would be for a customer who can purchase up to 5 cans. So that is our lesson on open sentences and solution sets.